Hi everyone. I am Prachi Jain. I'm from Princeton to the university. Today I'll tell you about Cauchy's mean value theorem. Basically, the mean value theorem of Cauchy is a generalization of Lagrange's mean value theorem. It is also known as second mean value theorem or extended mean value theorem. It provides a connection between two functions' derivative and change in the function over a specified interval. So let's take it a function fx is continuous in a closed interval ab and differentiable in a open interval ab, but there must exist at least one point where c is equals to, x is equals to c on this interval, and it is described as it is described by the normal mean value theorem. F b minus f b upon b minus c is f dash c. Let's understand the statement and proof of Cauchy's mean value theorem. First of all, to know Cauchy's mean value theorem, you should know that it consists of two functions. Let's take fx and gx. And to satisfy the mean value theorem of Cauchy, there should be three conditions which needs to be satisfied. So let's understand and know the conditions. So the first condition is that both functions fx and gx must be continuous in closed in a closed interval ab, and the function fx and gx should be differentiable in open interval ab. Then the g dash x does not vanish. The third condition is that the g dash x does not vanish at any point in ab. What does this mean? It means that g dash x is not equal to 0 at any point in ab. So by these all the three conditions, then there will exist at least one point in c, such c belongs to ab, such that f dash c upon g dash c is equals to fb minus fa upon gb minus ga. Let's understand the proof. So here gb minus ga is equals to 0. So let's take a function which is capital Fx, which could be defined as fx. The capital Fx is equals to small fx plus agx. What this a is? So here this a is a constant which is determined such that function of capital capital Fa is equals to capital Fp. Okay. So by this we can get that small fa plus aga is equals to f function fb plus agb, or could simplify it as minus a is equals to fb minus fa upon gb minus ga. So from first, the function fx and gx are continuous and differentiable, then fx is also continuous. Capital Fx is also continuous and differentiable. This is through Rolle's theorem. Okay. So yeah. And we know that capital Fc is equals to 0 as c belongs to AB. Then f dash c and agc is equals to 0 as the theorem we also know. So minus a is equals to fc minus gc. The third. So from the second and the third equation, you could find the most important Cauchy's equation, which is f dash c upon g dash c is equals to fb minus fa upon gb minus ga. It's a very small but easy theorem. You could understand it easily, and to understand it more easily, we'll explain it with examples. Okay, so let's take the first example. Let's take two functions. One is 1 minus x, and the second function is 1 minus x squared. So the first function will be fx. Fx is equals to 1 by x. And the second function, let's take it gx, which will be gx is equals to 1 by x squared. It belongs to 4 comma 6. So first of all, the first condition. What was the first condition? It should be continuous. So we know that it is polynomial, so it is definitely continuous. So both fx and gx are continuous, as well as differentiable in closed interval 4c. Okay. Then g dash x is equals to minus 2 by x cubed. What is this? This is derivative, obviously. So yeah. So here we can know that gx does not belongs to 0, is not equal to 0. So now we could know that from the Cauchy's equation is f dash c upon g dash c is equals to ft minus fa upon gb minus ga, and f dash x is equals to 1 by x squared. So putting the values in the function fa, the value of fa will be 1 by 4, and the value of fb will be 1 by 6. The value of ga will be 1 by 16 because it is a square, so it will be squared. And the value of gb will be 1 by 36. Now getting the derivative. So the derivative of c, xc is minus 1 by c square, and the derivative of g dash c, gc is minus 2 by 6 cube. So by substituting the values and putting in the equation, we get the following equation. Minus 1 by c square is equals to 1 by 6 minus 1 by 4 upon, just a minute, I'll put the wrong equation. 1 minus 1 upon c square upon minus 2 upon c cube is equals to 1 minus 6 minus 1 by 4 upon 1 by 36 minus 1 by 16. When we'll cross multiply it and put the equation simplified, we'll get the answer as 4.8. So the value of c is 4.8. It's very easy, and we could calculate it very easily through cross multiplication. So yeah, let's understand this, but let's understand it more clearly by another example. So here, the question states that if fx is differentiable and gx is not equal to 0, such that function f1 is 4, f2 is 16, fx is 8, gx, and g2 is 4, then what is the value of g1? So what this question is, we have given the value of a and b. So what a and b is? A is 1 and b is 2. It's simple. So what we have is, we know the formula. We have the equation of Cauchy's mean value theorem, which is f dash c upon g dash c is equals to f2 minus fa upon gb minus ga. The value of a is 1, the value of b is 2. So by putting it in the equation, like we have f dash c upon g dash c is equals to f2 minus f1 upon g2 minus g1. We have the values of f2, f1, and g2. So what we'll do is we put the values over there, and we have the equation also. Like this, you can see the equation is just fx is equals to agx. So we can do is we can replace fx. So we have to put 8gc upon gc, 8g dash c upon g dash c is equals to 16 minus 4 upon 4 minus g1. What we will do is we will get this cross multiply and get the equation. What the equation comes is 32 minus 8 g1 is equals to 12. When we get the 32 over there to the towards 12, then it would be, and dividing it by 8, we'll get the equation, or we'll get the answer by 5 by 2. This is the required answer. So G1 will be 5 by 2. We can understand this question more clearly. You can all understand this question when you solve it. It's a very easy theorem to understand, and I hope you all liked the video and you were able to understand the concept. Before ending the video, I would like to tell you about the important points which needs to be remembered doing this theorem. It is that we should check the continuity very importantly and differentiability, and the formulas must be applied properly. Please take care of this minus sign and dividing and derivatives and everything. Thank you so much. I hope you like it.